Recording. So, hey guys, on Ingalls, we're going to go ahead and start. And we were just discussing, today we're going to talk about circles and we're going to talk about the distance and midpoint formulas plus the formula for a circle. But before we start that, we have to have a little bit of background on the Pythagorean theorem. And I tell you, Pythagoras, what a great guy. I don't know. I didn't know him personally, obviously. But the theorems that he has and what he kind of came up with is a little bit mind-boggling in terms of how many times we use it. And it's my opinion, but I feel like the Pythagorean theorem is probably one of the most used theorems across the board in all of mathematics. I mean, because we're going to use it in not only just your geometry, obviously, but we use it in algebra. We'll also use it in calculus. They continue using it. They actually will, we use Pythagorean theorem in the trigonometry areas too when we start analyzing the triangles. So with that, when we talk about the Pythagorean theorem, they come up with what they call the distance formula. So if I have 2 points from x1, y1 to x2, y2, what they did by finding the distance formula, what they're doing is they're looking at the length of the legs and then they're also finding then the distance. Well, the length of the legs would be then x1 minus x2 minus x1. And then the distance of this leg would be y2 minus y1. And they're saying, well, so this one would be distance squared would equal then the absolute value of x2 minus x1, which is the distance, squared plus the absolute value of the x2 minus or y2 minus y1 expression squared. So what they're saying is by deriving the Pythagorean theorem, which is simply a squared plus b squared equals c squared, they come up with the distance is going to equal the square root of the difference between the 2 points and the expression squared, and then the square root of that. So finding the distance, couple of points. So here's a couple examples that we have. So if I have 2 points, 10, 10, 2, and 2, 8, then applying the distance formula, all I'm going to do is go ahead and subtract them. Because I'm squaring them, remember on slope, you had to be really particular. If you start with this point, you got to make sure you start the bottom with that point as well, because it changes the positive, negative value of your slope. But since we're going to square this, it really doesn't matter. But I just kind of get in the habit. If I start over here with 10, so I go 10 minus 2, those are the two x values I'm subtracting. I'm going to take that expression squared. Plus, then I'm going to also I'm going to just keep it the same, 2 minus 8 expression squared. And then I'm going to take the square root of all of that. So 10 minus 2 would be 8. 8 squared is going to be then 64. And then 2 minus 8 would be then 6. Squared that would be 36. And then I have the square root of 100. And that is going to be then the value of 10. And since we are dealing with a distance, I won't have to worry about the plus and the minus like normally you would have that squared part. Keep in mind that is also what we call a Pythagorean triple. Have you ever heard that term before? Pythagorean triple, what is kind of cool, there's a few triangles that you get whole numbers in here. And the 3, 4, 5 is considered a Pythagorean triple, where the two legs are 3 and 4 and the hypotenuse is 5. Well, in this case, notice I didn't get 5, right? I got 10. So it works then, Pythagorean theorem, it starts off with that, but we know similar triangles by multiplying everything by 2, then this would be then 6, 8, and 10 would also be an example of Pythagorean triple. There's also a really common one, another Pythagorean triple, and this is just kind of a side note, guys, is going to be 5, 12. Anyone have a guess here? 5, 12, and 13. Now, all of the other ones, so many more of your right triangles are going to have either a radical as one of their, as either the leg or the hypotenuse. But again, like if I multiplied everything by 3, if I had 15 and then, oh, 3 times 12 would be what, 36, and then 13 times 3 would be 39. That's also another Pythagorean triple. And that just means they come out to be whole numbers. Well, this one's obviously not a whole number, but it's still a fraction, and we can still apply the distance formula. So in this case, I'm going to take 16 minus 16 thirds minus 1/3 expression squared. And then I'm going to also go I'm going to go ahead and go 1/5 minus 6/5 expression squared. So if I do this, I've got the common denominators, so I'm good there. So 16 minus 1 is 15. 15 over 3, 5. I'm going to do that next step. I'm going to go 5 squared then, just to go, and then a plus. On this next one, I'm also going to go, uh, I'll have 5 over 5, and 5 over 5 would be 1. So it would be then 1 squared. And so 5 squared plus 1 squared is going to be then 26. Agreed? And then I'll have the square root of 26. And then you can, those of you who have that special little the calculator that quickly reduces your radicals. But if I think about it, my factors of 26 are 2 and 13, and nothing is going to be a perfect square. So that's the best I can do is the square root of 26. Okay? It's as simplified as it can get. Now, the midpoint is going to be that point. We're going to actually use this one also for our formula for a circle, but it's going to be the point that's halfway between. And I almost like to think about it in terms of you're averaging those, because if I think about an average, I'm going to add up my values and divide them by the total point. Like if I add up your grades, if I average your grades, I'm going to add up every one of your grades, and then I'm going to divide it by the total number of grades I had. Well, you have 2 points. So if I'm averaging this, then I'm going to add the 2 values, and then I'm going to divide it by 2. So, but it's written as a coordinate form. So my formula is actually in coordinate form. So I'm going to make a big coordinate, and I'm going to go ahead and add these together. So I'm going to have 10 plus 2. Oops, gosh, I just did it on I went ahead by my brain, and I'm dividing it by 2, comma, because this will be my x value, and then I'm going to have my y value. So I'm going to go 2 plus 8 divided by 2, and then I'm going to simplify my coordinate. So 10 plus 2 is going to be 12, divided by 2 is going to be 6. Okay, on the next one, I've got 8 plus 2 and over 2, and that's going to end up being then 10 over 2, which is going to be 5. And so if I were to look for my coordinate, my halfway between 10, 2, and 2, 8, then halfway between is going to be like 6 comma 5. Okay. I can also remember I don't have to have like nice whole numbers to do my midpoint. So on my midpoint, I can still do radicals. So on this one, my x value is 2 and negative 10. So remember, I'm adding it. So it's really 2 plus a negative 10 divided by 2. And then on the next one, I'm going to have 3 square root of 6 plus 7 square root of 6 all over 2. And on the first one, I'm gonna take 2 plus a negative 10, and that's gonna give me a negative 8. And then I'm gonna divide it by 2. So negative 8 divided by 2 would be good. Then on the next one, I'm going to still go ahead and do 3 square root of 6 plus 7 square root of 6. Remember, because they're both the square root of 6, that means I add the coefficients in front. So that is going to be 10 square root of 6 divided by 2. And I want you to be real careful on this one. Remember, you can simplify everything outside of the radical. Like on this one, the 2 is not underneath the radical. So I can take 2 into 10 and reduce that to 5. So my answer is going to be negative 4 comma 5 square root of 6. But never put the 2 under the radical. In other words, I wouldn't cancel that with a 6 and say that I had square root of 3. You can't go a number outside the radical and reduce it from the number inside the radical. Okay. Also, remember, I had to have both of these as a square root of 6 for me to add them together. So if it happened to be a square root of 3 and a square root of 6, then you won't be able, you just leave it like that, okay? So just remember your little rules that we have. Now, the definition of a circle is going to be all the set of the points from the center that are equidistant and we from a fixed point in which we call which will be the distance is going to be that radius. And so notice when we have the standard form of equation of a circle will be in the form of x minus h expression squared plus y minus k expression squared is equal to r squared. Notice that, remember, when it's inside the function, it's going to look like the opposite. So when I put it back, I've got a center at -2 comma 0 and a radius of 9. I'm going to do the extra steps. So I'm going to go I'll end up with minus a minus 2 expression squared plus y minus 0 expression squared is equal to the radius is 9, so it's going to be 9 squared. So don't forget you're going to not well, in this I'm going to have then a minus. Remember that's going to change that to plus. So my actual answer will be x plus 2 expression squared. But then I have y minus 0. I don't even need that y minus 0, so I'm just going to go plus y squared is equal then to 9 squared or 81. Okay, so inside your function, it's going to look like the opposite. So if I ask, like when you look at this with the center, that's why this is going to look like the center will be at -2, and if it's a minus, it's going to be then a positive. So here's one that's going to be a positive. So we're going to start off with x minus 3 expression squared plus y minus 4 expression squared. And I have the square root of 3 then squared. And then to simplify it, you could expand this out. But if they're asking for the standard form, then they're looking for just this equation here. And so the only thing I would do then is take the square root of 3 and the square root of 3 squared and just get that as 3. So the answer will be x minus 3 expression squared plus y minus 4 expression squared. So pretty easy, correct, so far? Now this time I'm given the equation in standard form, and I'm asked to go ahead and find the center and asked to find the radius. So remember on this one, if I have just x squared and y squared, remember when we did that before, when we had the y squared and we simplified it, the y value was just 0. So this one is going to tell you my center is going to be at 0, 0. Very good. We need to remember that this is representing r squared is going to be 49. And so actually then the r, the radius by itself, would have to be what? 7, right. You're going to take the square root of it. So don't forget, I do see that often that they'll just go ahead and tell me that it's going to be 49. Now, this one is going to be obviously not at 0, 0. And we need to remember, like we did before when we shifted right and left, it's the opposite. So my x value of my center is going to be at what? Did I hear 3? Yes. What about my y value? Positive or negative? Ooh, go the opposite. Yes. So because it says it's a +4 here, do the opposite, and it's going to be then a -4. Just like over here, this one looks like a -3. You want it to look like the opposite of that, so it's going to be a +3. Does that make sense? And then remember, r squared is equal to 12. So I'm going to take the square root of both sides. So I'm going to go r is equal to square root of 12. This time I don't want to leave it that way. And again, you guys have the advantage. It is because again, if you don't have a calculator for that, remember you're thinking about 4 times 3, and the square root of 4 just is going to be 2 outside. So you're right. The correct answer is 2 radical 3. So 2 square root of 3 is going to be your radius. All right, so now we're just going to go ahead and graph this. So again, if you're asked to graph it, you're going to look for the center, and you're also going to write the radius just like we did before. So in this problem, my center is going to be at 3 comma 2. Both of those look like they're negative, so they're going to make them positive. And then my radius is going to be square root of 36, which is 6. So what you'll do is you'll start by graphing 1, 2, 3 and come up 2. And then what I'd like you to do is go in 4 directions, the radius. So 1, 2, 3, 4, 5, 6. I'm going to go out 4, 6, 1, 2, 3, 4, 5, 6. And then I'm going to go up 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6. Well, and then just try and get as close as you can. But we're going to talk about the domain and range. So if you think about it, okay, we're going to use this to identify the domain and range. Remember, the domain are going to be your x values. So I'm going to look here. I started here, my x value was 3, but then I went back 6, right? So that means this point is actually going to start at -3, right? 3 minus my radius, which is going to be 6, which is going to be -3. And I'm going to go all the way until I go past the center and go 6 more. 9, good. And I didn't ask you this, but I'm going to include those points. Therefore, it has to be a bracket. Okay, but let's do the range. We're going to do the same thing, but this time we're going to look at the y value. So we're going to come up here. We have 2. We're going to go 6 in both directions. 1, 2. I didn't quite get 6 on my little ant, so I'm going to quickly change that. So I'm going to go down 6 from 2. So 2 minus 6 is going to be good. And then 2 plus 6, 8. And then I know I'm going to include the brackets on both of those. So that would be my domain and range. Any questions so far? Awesome. Um, the general form just means that they've expanded it. Okay. So this is an example of a circle that's in the general form. And a lot of times this is also when I take and stop and do a little bit with conic sections. Now, conic section just means that I have 2 cones that are cut by a plane. And you can have a lot of different pictures of that. And I forgot to grab my pictures of my conic sections, but one of them will always be a circle. Like, so if you imagine 2 cones and you have a plane that's actually just splitting that in half, it will be, then it will create what's left as a circle. You always know this is a circle because you have 2 squared terms and both of the coefficients in front of the x and the y are exactly the same, and they're both positive. If you had one that's negative, it would change it to a hyperbola. If you had 2 different numbers, it makes it an ellipse. And so I'm kind of just giving you a little out of there, but this time we're going to complete the square, which I know you guys loved, right? With parabolas. Woohoo! We get to do it again. But when we complete the square, what you want to do is you want to group together your x's and your y's. So I'm going to start off here. I'm going to start off with x squared. Then I'm going to end up with then plus 4x. I am going to leave purposely a little room because I'm going to complete the square. Okay. Then I'm going to write my y values. So then I'm going to go plus y squared. And I'm going to go minus 4y. I'm going to leave a little room here. And then I'm going to set it equal to, and I'm going to move that 17 to the other side. Okay, so I'm going to just add it to both sides, so it's going to be equal to 17. All right, remember we took the middle term, which is in this case is 4. We divided it by 2, good job, and then we squared it. So 4 divided by 2 is going to be just 2. Squared is going to be back to 4. So that means I'm going to add 4 to this side. Goodness gracious, I think I'm breaking my lead all the time. Well, it's the same thing over here. And so I'm still going to add 4 to this side because I'm going to take 4 divided by 2 and then square it. Well, I just added 8 to this side, correct? If I go to the other side, I must add 8 to the other side as well. Or let me just change. I probably should have gone 4 plus 4. Okay, if you want to just remember you're going to add both of those terms that we're to use to complete the square. We're going to put those in. So then I'm going to say factors of 4 that add up to 4, which are 2 and 2. So that's when I'm going to create my parentheses, expression squared. I'm going to have 4 and or x and 2 Sign between plus y. Yep, they're both positive right there. But then the y changes. So then I'm going to go y. I know it's going to be 2 expression squared, but this time what's the sign going to be? Minus because of that minus right there. So minus 2, good job. And then I have equals 17 plus 4 plus 4, which is going to be 25. Okay, so my center is located at, perfect, -2, comma 2, and my radius is going to equal 5. Okay, so that completes, oh, we're going to have to do one more. We're going to do one more problem, and this one, I wanted to do one that we didn't have the same. So again, I'm going to complete the square, write the equation in standard form, and then find the center and graph it. So the only thing new on this one, we're going to graph it. So I'm going to start off with x squared. I'm going to have minus x. I'm going to leave a little room. And then I'm going to go plus y squared plus 6y. I'm going to leave a little room. And then I'm going to go equals then a negative 9. No problem so far? Okay. This one's going to be a little different because my middle term is just going to be 1. So I'm going to have 1 divided by 2, and I'm going to square it. Yes, so I'm going to add 1/4 right here. But then I'm going to go over on this side and go plus 1/4. Now this one's not as bad, so I'm going to go 6 divided by 2 and square it. 9, so I'm going to add 9 here. So I'm going to go plus 9. They do, yep. So we're left with 1/4, okay? So now I'm going to complete the square. So I'm going to go ahead and I'm going to have x. I'm going to have expression squared. Remember, it's going to be the square root of this term, or it's the number, the middle term divided by 2. So this number will be 1/2. Very good. The sign in between will be negative. Awesome, because of the fact that you're going to minus. And that kind of makes sense because if you take the factors of 1/4, which is 1/2, would be 1/2 and 1/2. 1/2 plus 1/2 is going to be 1. And that's where we're getting the negative 1. So plus then I'm going to have this one. I'm going to go y. I'm going to go expression squared. Plus or minus? You want to start with that one? Plus what? 3, good. Get factors of 9 that add up to 6. And then I'm going to have equals. Remember, my 9's canceled out, so I'm left with 1/4. And so the last thing, my center is at, yep. And my radius is going to be the square root of 1/4, which would also be the same as 1/2. Good. And so they've kind of made our graph so that it works with, like this is going to be right here. This point would be then 1. So if I'm going to go, the center is 1/2. That means it's going to be over just to the first line. And then I'm going to go down 3. So it's going to be 1. Right, should be right there. And then I'm going to go a radius of 1/2, which is just going to be this one little point right there. All right. Good job on completing the square. Stop sharing and we'll end.